Good morning. I am Reggie, Associate Professor, Department of ECE. Today we are going to discuss about microwave power amplifier design. Microwave power amplifier design. On completion of this topic, students can understand what is meant by microwave power amplifier. Draw the input-output characteristic curve for microwave power amplifier. Introduction to radio frequency signal. Electromagnetic waves are generated when electrical signal pass through the conductor. EM waves start to radiate from a conductor when the signal frequency is higher than the highest audio frequency, which is approximately 50 to 20 kHz. Because of the radiating property, signal of such or higher frequency are known as radio frequency signal. Reason for RF or microwave. Wider bandwidth due to higher frequency, smaller component in size leading to smaller system, more available and less crowded frequency spectrum, better resolution for radar due to smaller wavelength, low interferences due to lower signal crowding, high speed of operation, higher antenna gain, possible in smaller space. RF or microwave application. It is mainly used in communication, TV and radio broadcast, optical communication, radar, navigation, remote sensing, domestic and industrial application. Characteristics of amplifier. The most important and complex arc is the amplification of input signal through either a single or multi-stage transistor circuit. A generic single-stage amplifier circuit embedded between input and output matching network as shown in figure. Input and output matching network are needed to reduce undesirable reflection and thus improve the power flow capability in terms of performance specification. The following list constitute a set of key amplifier parameters. RF amplifier, gain and gain flatness, operating frequency and bandwidth, output power, power supply requirement, input and output power fluctuations, noise figure. So consider the diagram, generic amplifier design. We will have the RF source, input matching network, S parameter, output matching network, load. So from the RF source, input matching network is given in order to perform the input and output matching. Then it is given to S parameter. Output matching can be done to control the output. Amplifier power relation. So the equivalent diagram of this amplifier design, we are having the input source with S parameter and you are getting the output. The equivalent circuit diagram is shown below. So the signal flow diagram for RF amplifier. Consider it is a two-port network, so it is having the parameter S11, S12, S21 and S22. Reflection RF amplifier, when we are going to calculate the value, reflection coefficient seen looking towards the load, gamma L equal to ZL minus Z0 by ZL plus Z0. Reflection coefficient seen towards gamma S is equal to ZS minus Z0 by ZS plus Z0. Input reflection coefficient gamma n is equal to S11 plus S12 S21 gamma L divided by 1 minus S22 gamma L. Output reflection coefficient gamma out is equal to S22 plus S12 S21 gamma S by 1 minus S11 gamma S. From the signal flow graph, it is understand that Bs plus A1 dash gamma S is equal to B1 dash. So Bs is equal to B1 dash minus A1 gamma S. When you take the common term outside, Bs is equal to B1 dash 1 minus A1 dash by B1 dash gamma S. So Bs is equal to B1 dash 1 minus gamma in gamma S. So B dash is equal to Bs by 1 minus gamma in gamma S. So the input power wave associated with B1 is Pinc equal to B1 dash the whole square by 2 and Pinc is equal to 1 by 2 Bs whole square by 1 minus gamma in gamma at the whole square, which is the power launched towards the amplifier. Gamma n equal to 0 and gamma s is equal to 0. So power incident is equal to Bs square by 2. The actual input power is absorbed at the input terminal of the amplifier is composed of two waves, incident wave and reflected wave. So power input is equal to power incident into 1 minus gamma in the whole square. That is power input is 1 by 2 Bs square by gamma in gamma S. That is 1 minus gamma in the whole square. Maximum power transfer from the source to the amplifier is achieved if the input impedance is complex conjugate method or in terms of reflection coefficient. Under maximum power transfer condition, the available power Pa is equal to P in gamma in equal to gamma S. Pa is equal to 1 by 2 modulus Bs square by 1 minus gamma in gamma S the whole square into 1 minus gamma in the whole square. Available power 1 by 2 Bs square by 1 minus gamma S the whole square 1 minus gamma S the whole square. So the power delivered to the load is given by PL is equal to 1 by 2 B2 square into 1 minus gamma L the whole square. Transducer power gain. The performance parameter of the amplifier begins with transducer power gain GT is denoted by the letter GT is equal to power delivered to the load by available power from the source. GT is equal to PL by hour, PL by PA. PL is equal to 1 by 2 B2 square 1 minus gamma L the whole square. So G2 is equal to 1 by 2 B2 square into 1 minus gamma L the whole square divided by BS square by 1 minus gamma S the whole square. GT can be also written as B2 by Bs the whole square 1 minus gamma L the whole square into 1 minus gamma L the whole square. The reflected wave at port 2 is B2 is equal to A1 S21 by 1 minus S22 gamma L. By rearranging the equation you will get A1 is equal to B2 into 1 minus S22 gamma L by S21. The source reflection coefficient Bs is given by Bs is equal to 1 minus gamma S gamma in into A1. So the input reflection coefficient is given by gamma in equal to S11 plus S12 S21 gamma L 1 minus S22 gamma L. By rearranging the equation you will get the values corresponding to this input reflection coefficient and output reflection coefficient. In order to find out 1 minus gamma S gamma N, we have to substitute the value 1 minus S11 1 minus S22 gamma L into gamma L by plus S1 to S21 gamma L gamma S by 1 minus S2 gamma L. So using this value we will find the value of Bs. Bs is equal to 1 minus gamma S gamma into A1. So substituting the value, both the value can be rectified. You will get Bs by B2 the whole square is equal to 1 modulus S21 the whole square by 1 minus S22 gamma L minus S1 gamma S minus S1 to S21 gamma L gamma S the whole square. So from this value of transducer power gain can be determined GT equal to B2 by Bs the whole square 1 minus gamma L the whole square 1 minus gamma S the whole square. So from this the transducer power gain can be calculated. The special case are matched transducer power gain, unilateral transducer gain, maximum power gain, additional power relation are available power gain and power gain. From this we are going to do one problem. So an amplifier as the S parameter is given, source voltage is given, impedance is given, impedance ZL is also given. You have to find out transducer gain, unilateral transducer gain, available gain, power delivered to the load, available power and incident power. So first of all you write the given data, you substitute the formula. So gamma L equal to 0.187, gamma is equal to minus 0.11. From this we can predict these values. Corresponding to these values you will get Bs is equal to 0.392 and gamma L value can be computed and is approximately is equal to 0.3 at an angle minus 70 degree. That is gamma in is equal to 0.2 at an angle minus 45 degree. Gamma out can be computed and its value is found out to be 0.445 minus 53.42. So available transducer power gain GT is equal to 12.556, GT in dB 10.988 dB. So similar way we can compute GTU 12.68, GT in dB 11.03. So using those value we can calculate all those terms corresponding to gain, that is 13.75. So power delivered to the load, power incident equals 0.0733 watt and power in dB equal to 18.65 dBm. So basically we can calculate available power is equal to 0.778 using the formula what we derived from this equation. So finally we will get PL in dBm is equal to 28.89 dBm. So from this students can understand what is a power amplifier, how we can derive the transducer power gain, available power gain and efficiency. Thank you.